Hi, welcome to This is Homeschooling. I'm Kat Hutcheson, your guest host for this episode. Today we are welcoming scientist, author, founder of Homeschoolers, Blair Lee, to talk about her amazing interactive science course, Microbiology. Hi, Blair.
Hi, Kat. Thanks for doing this.
So I want to dive right in. This is a much loved curriculum in the C community, and I know we have lots of people who are going to want to know all of the details about it. So could you start by telling me who you wrote this course for?
It's for fourth to seventh graders. I've had people use it for younger kids, older kids. It's we're homeschoolers. There's a really generous sample. Just make sure that it works at the age and stage your child is right now.
What's included when someone buys this course?
So, of course, you get the book, which is not in print, but we are by the time micro marine science comes out, both of these will be available if you want a print option. So you get the course materials, you get an extensive PDF with teacher's guide, answer key, everything you could want to make this course as easy on the teacher side of things to teach from. And then there's the videos. And I really think the videos are what makes this course, one of the things that makes this course so special. I work really hard to make the course itself visually appealing, as you can see. I'm trying to get to like really beautiful pictures and kids. It's really interesting. Science courses didn't used to be that visual, but kids, in my opinion, need that visual stimulation when they're learning science. I never want kids to think of science as dry and boring. And frankly, microbiology, especially when you're looking at the visualization of what you're talking about, is incredibly fascinating. I mean, it's an entire world within our world that we can't see, and so most of us aren't aware of. Now, the videos themselves were so as I was teaching the class, I was pulling videos from YouTube and I was realizing they were using vocabulary that I wasn't using in some cases. They were either too easy or too challenging, the concepts they were talking about. And I really wanted kids to be able to have a resource where I could highlight the concepts through video that I was talking about to sort of build out from the principles I was talking about. And most of the videos are animated, but not all of them. There are some videos of me showing kids certain lab techniques. And I really believe that it makes it a very special course.
Well, I agree. The videos you created make this course so special, and it's such a great component of multimodal learning. And this is part of the hands on science series. So, how do you bring in the hands on component of multimodal learning with this course?
So every chapter has a lab or activity. I had to get pretty creative on some of them. For example, I mean, you're at home. How are you going to find these microbes? But we managed. There's some modeling. Look, the I in order to get a holistic learning experience, you want the reading, writing component, you want the visual component, you want the auditory component, you need the kinesthetic component. And I am well known for my position on hands-on science. If you are not practicing the practices of science, you're really the learning around it is inadequate, and it's not how scientists think of science. Science is a doing a learning experience. In the same way that you'd never think you could learn to oil paint unless there was some painting involved. There's no way you can learn science unless the doing of science is also involved.
You mentioned the reading writing component of multimodal learning. Could you tell us how you incorporate that into this course as well?
So there's a problem set with the course, and there's some short answers as a part of that, some multiple choice and different things as a component of that. If you have a child that writing adds a lot to their cognitive load, you can use those as discussion questions, which isn't a bad idea anyway, because through discussion questions, you're really working on metacognitive skills, which is a good thing. But I think what you're really referencing, Kat, is that there are thought questions, vocabulary sections, um, and check for understanding sections that are actually built into the text of the science course. If you've ever read a page in a science textbook and gotten to the bottom and thought, what did I just read? Hey, I'm telling you, it's happened to me so many times. And so I didn't want that to happen to kids. A lot of the teaching in this is around things that is completely new. I mean, most kids don't have a lot of learning around microbiology in fourth through seventh grade. And so these check for understanding, after there's sort of a complicated piece of science, the check for understanding is basically my way of saying, let's stop right there and make sure that you understood what you just read. Or where there's a lot of new vocabulary, I'll have kids stop just to check in so that they can, and again, this is actually retrieving what they just learned as a component of mastery of that vocabulary and of those concepts. I do this especially when it's a concept that I've taught in, for example, chapter 2, but that concept's going to show up in different places throughout the course. One of the things I do when I write courses is the first section is, I like to think of it as front loading. There's a lot of information initially, and the reason I do that is because here's some of the core foundational concepts and information and vocabulary you're going to need, and then you're going to use it in a conceptual and contextual way throughout the rest of the course. In that way, you get real mastery around these concepts and of the vocabulary. It's actually one of the things that you need to really learn or remember something is you have to forget it a little. So it's important that you teach something in chapter 2 and you come back to it maybe in chapter 4. And maybe a text box is right next to it in chapter 4 for those kids who are like, I remember, but I don't totally remember. And you're just helping them. And in that way, you're ensuring that a space for that information is made in long-term memory.
Could you tell us a bit about the microbiology topics kids will learn about in this course?
Absolutely. There's 12 chapters divided into 5 units. The first unit is, as I mentioned, it's where I front load information, like what is microbiology, genetics, and what does immunity mean, your immune system. Those are covered in the first unit. Then bacteria, and this is really fun. I had so much fun with this. I fascinating. It's such a fascinating area of science. Kids will learn really important science in it, and they'll learn that the reason you fart is bacteria. So there's some funny whimsy. You'd want to have that whimsy to hook kids in and get them learning. It's really effective, even for adults. Then we go to viruses. Uh, Viruses have got to be one of the most fascinating areas. And viruses affect things like the definition of what is life. The exobiologists at NASA really seems to me think that the definition needs to be rewritten to include viruses, because if you were on another planet and there were viruses, would you consider those living? They're awfully close to life. So maybe we should. And then microbes make history. This is where I cover CRISPR and some of the techniques that are being used to harness the power of microbes and to make new vaccines, these cutting edge vaccines that are being made that identify a protein. If your child learns this course, they'll be able to explain why some of the new vaccines could never give you the virus because they don't include the infectious particle at all. Then I cover pathogens, which is a fascinating part of human history, and possibly are the reason pathogens might just be the reasons why mammals are the dominant organisms at this time in the evolutionary history of our planet. Eukaryotic microbes. It's a fancy way of saying microbes that have a nucleus. That is the final unit covering fungi, algae. I bring CRISPR back into that because the biofuels that are being made are harness and use some of those techniques. And then protozoa. These are all it really the core topics and concepts that you need to understand microbiology. And if your child uses this course, the next time they get to as complete a covering of this topic, unless they take microbiology in high school, and there aren't that many microbiology courses available, although who knows? I haven't been over to Alt School lately. You never know. The next time they'll get a course this complete covering microbiology will be in college. It is that type of foundational information. But I would also argue that this information will help expand their understanding of biology as a whole.
So I know that this course is much loved by people in the C community, but it's also loved outside of the C community. In fact, you got a fantastic review from Andrew Hessel, who is chairman of the board of Human Genome Project Right and is working at the forefront of some of these new microbiology technologies that are happening. Could you tell me a little bit about what he said and how that happened?
It took, well, first of all, it's kind of funny. I called Kat. I'm like, I'm so nervous to even ask, but hey, what's the worst someone could say? No, right? He was more than happy, told me that if I ever do a update it, that he'd be happy to review it again. That is how important he thinks it is that kids learn this topic. I'm going to tell you, this is a cutting area of biology. And it doesn't, it because of the effect the microbial world has on the macrobial world, this is not just a small area of biology. And I think people are really coming to be aware of that. People are winning Nobel Prizes for microbiologists are winning Nobel Prizes. If you've got a kid that is interested in science, especially biology or biochemistry, I would argue that microbiology shouldn't be treated as sort of an elective. It should be treated as a core part of their learning. And even if you don't have a kid that's interested in that area, they will have an understanding. One of the reasons I think science is so important is because the impact it has on our daily life. And I don't know if you can tell, but I have a bit of a cold caught from my um, grandson, and I passed it along to my husband. So he's not feeling too good today. And I, it actually is one area of science that you can make a really strong argument for the importance of knowing something about it because it affects your health. Flat out, for sure, affects your health. I was so proud of the recommendation from Andrew Hessel.
So, microbiology sounds like a really complicated topic. And I know that one thing that I love about your science courses is you are so skilled at taking these high level, complicated science topics and making them really accessible for younger learners. Is there any science prereqs or anything that kids should know before taking this course?
No, that's the whole thing. When I talk about this front loading, I take the time to teach your child what they need to know, the core things that they need to, the background things that they need to know so that they can, so that when those are brought up and discussed throughout the course, they have already learned what those things in the first 3 chapters. It's something that is really important to me, because I don't assume that your child has had this science, and I don't assume that you have a background in science. That's really important. Both you and your child, you will be able to help them, because what they need to know is either in the course, or the teacher's guide does have some teaching notes for you, and it's everything you need.
So, as you've been telling us about this course, I can tell that you get really excited about this topic. As a scientist, what did you find most fascinating, or what did you get the most excited about as you were writing this course?
So I this was so much fun, and it was it's an area of science I had in college, and actually found really fascinating in college. But I this information, it's profound because of the impact that microbes have on the entire world. I mean, it's absolutely fascinating. I really delved into the evolutionary history of microbes. Did it start as an RNA world, a DNA? I mean, I really geeked down into all of this. But the most exciting part, because I'll be really honest, is what turned out to be making the videos, distilling down, because it was a totally new skill that I learned, figuring out the videos are like me being there teaching your learner things. So, for example, every lab starts with why you're doing this lab, the practices you're going to learn, the procedures you're going to learn, the lab techniques you're going to learn. These are things that if I were teaching a college class on this topic, this is how I would start the labs of my college class. And so to be able to provide that all in one and tailored to the text, as an educator, I was pretty exciting just to bring it all together, and it worked. I mean, I wrote it, so take this for what you will, but I think I really nailed it. It's got all the components that you need to teach something.
Well, I think you nailed it too. And my kids think you nailed it. My kids love the videos. Cartoon Blair, such a hit in my house, even with a 10-year age gap between my kids. When this came out, one was kind of old for it and one was kind of young for it, and they both loved all of the videos because they watched the entire course through. Blair, thank you so much for coming on and sharing everything about microbiology with our audience today. For everyone who is watching this video, there is a link in the description that will take you over to See Books and More, where you can check out microbiology. There are lots of sample pages and sample videos you can watch so you can find out if this is a good fit for your learners.
Thank you for watching this, everyone. And thanks for checking out microbiology.